So this is the problem. 2 sine square pi by 6 plus cosec square 7 pi by 6 multiply by cos square pi by 3 we are to prove equal to 3 by 2. So left hand side is equal to 2 sine square pi by 6 plus cosec square 7 pi by 6 multiply by cos square pi by 3. Pi by 6 is 30 degree. Sine of 30 degree is half. So it is square of half. Cosec of 7 pi by 6 we write as cosec of pi plus pi by 6. And we are to take its square. Cos pi by 3 means cos 60 degree. It is half, whose square has to be taken. This is 2 multiplied by 1 by 4. Now cosec of 180 plus theta formula is minus cosec theta. But the square will make it again plus. So cosec square pi by 6 multiply by 1 by 4. This is 1 by 2. Now cosec of pi by 6, cosec 30 degree, it is 2, reciprocal of sine 30 degree. So 2 square multiply by 1 by 4. 2 square is actually 4, it cancels. So half plus 1 equal to 3 by 2, which is equal to right hand side. Is it clear?
So yes.
So next, proceeding to the next problem. Values of, we are doing trigonometric functions at angles in radian. This is the next problem. Here left hand side is equal to cot pi by 6 means cot 30 degree. Cot 30 degree is root 3. So it is square of root 3. Cosec 5 pi by 6. We can write it as cosec of pi minus pi by 6 plus 3 times tan pi by 6 is 1 by root 3. Tan 30 degree actually. Put square. This is root 3 square is 3. Cosec of 180 degree minus theta is cosec theta. It is cosec of pi by 6. 1 by root 3 square is 1 by 3 only. This cancels actually. This is 1. Cosec pi by 6 means cosec 30, reciprocal of sine 30, that is 2. So this is 3 multiplied by 2. And actually there was plus in between the first two terms also. So here it is 3 plus 2. So 3 plus 2 and plus 1, which is equal to 6, which is right hand side. Is it clear?
Yes, sir.
So next, just wait for a minute. Let me take your attendance. So next I open. This is again the problem, one more problem left of the same kind. Here left hand side is equal to 2 times square of sine of 3 pi by 4 can be written as pi minus pi by 4. Sine 180 degree minus theta form. 2 times this is square of cos pi by 4. Cos pi by 4 means cos 45 degree. 1 by root 2. 2 times square of secant pi by 3, secant 60. That is reciprocal of cos 60. Reciprocal of half. So this is 2. This is 2 times sine 180 degree minus theta is sine theta. So it is sine 45 degree. Sine pi by 4 we can write. It's square. Root 2 square is 2. Cancels with 2. Leaving 1 here. This is 2 multiplied by 4. This is 8. Sine pi by 4 again. It is 1 by root 2. Whose square is 2. Cancels. Only 1 is left. This is 1 plus 1 plus 8, 10, which is right hand side. So these were a few questions of this kind. I think this much is clear.
Sir, yes.
Yes, sir.
So now I am going to the new formulae, which we call as complementary angle formulae. I am taking the next page now. Complementary angle formulae. Pi by 2 is there. Pi by 2 stands for 90 degree. All these formulae in degree system, you can say sine 90 minus x cos x. Cos 90 degree minus x will be sine x. Tan will convert into cot. Cot will convert into tan. Secant will convert into cosecant. Cosecant will convert into secant. So if you have three functions, sine, tan, secant, these don't begin with the word co. These are without co. So these functions change to the corresponding function beginning with co. Sine becomes cosine, that is cos. Tan becomes cotangent, matlab cot. Secant becomes cosecant. And if you have the functions of these kinds, cos, cot, cosecant, which begin with co, then co is removed. This is happening here. Sine is changing to cosine. Cosine changing to sine. Tan changing to cotan. Cotan to tan. Secant to cosecant and cosecant to secant. This way we can remember these formulae. But I have told you how to remember these formulae. These are very simple. In the 10th class, if x were an acute angle, these formulae were there in that syllabus which was actually deleted. So I have taken this diagram for the acute angle just to make the things basically clear. If this angle is x, because it is a right triangle, this angle is 90 degree minus x. So suppose this point is O, this is A, this is B. If we want to find sine of pi by 2 minus x, that means sine of 90 degree minus x, this angle. For this angle, perpendicular is OA. And hypotenuse in opposite to the 90 degree angle is OB. So OA upon OB. But for the angle X, if you think, OA is base for angle X. OA is the base and OB of course is the hypotenuse. So OA upon OB is equal to cos X. I hope you got it. Yes. I hope this is clear.
Sir, kindly repeat it.
I repeat it. Okay, 1 minute. Here is, I have taken in this right triangle an acute angle x first. Though in this formula, x can be any angle, we will prove in the modern concept also. If for any angle x, these formulae are true. But in 10th class, deleted syllabus actually. So you must have not done this. So if this is an acute angle x, this is 90 degrees. This angle will be minus x. So if we want to find sine of 90 degree minus x, means sine of pi by 2 minus x. For the angle 90 degree minus x, we won't say the AB is perpendicular. Perpendicular is that side which is opposite to the angle we are taking for trigonometric ratio finding. We want to find a sine of this angle. So for the determination of sine of this angle, the perpendicular is OA. Hypotenuse is always opposite to the 90 degrees, so that is always OB. But if we find cos of x for the angle x, perpendicular is AB, but base is OA. So OA is the base for angle x and OB is the hypotenuse. So OA upon OB, which is sine of 90 degree minus x, is actually cos of x. I think, is it clear now?
Sir, yes.
And one more, if we find cos of pi by 2 minus x, means we want to find the cos of this angle, 90 degree minus x. This is perpendicular, this is base for this angle. So base is AB, hypotenuse is OB, base upon hypotenuse is cos. But for angle x, AB is the perpendicular, OB is the hypotenuse, so it becomes sine x. So this is a simple reason why we call these complementary angle formulae, because for the angle x, 90 degree minus x is its complementary angle, because complementary angles are those whose sum is 90 degree. Okay.
Sir, yes.
So
Sir,
similarly,
yes.
you can prove very easily for this acute angle x, the tan will change to cot and cot will change to tan, secant to cosecant, cosecant to secant. You can do it as a homework. If any doubt, we can get it done tomorrow. But now I am going to prove these formulae. It's not a difficult thing now. In general, for any angle x, so for the time being, I remove this triangle also. There is no use now. For any angle x, how we prove these formulae? It is not difficult. We have proven yet two formulae. One is cos of x minus y is equal to, yes, who will tell? Cos of x minus y is equal to cos x cos
Into
y
cos y
plus
plus
sin
sin x into
sin.
sin y.
And another formula we have proven cos x plus y, but we won't use yet. So we take x equal to pi by 2 and y we replace by x. So we have just name of the variable is x. Angle can be named y, angle can be named x, u, v, w, anything. So I have taken the value of x equal to constant pi by 2 and y variable's name has been changed to x. So same formula will tell us this equal to cos of pi by 2 cos of x plus sine of pi by 2 into sine of x. What is cos pi by 2? Means cos 90 degree. Cos 90 degree is,
So,
what is cos 90 degree? We have done 0, yet not remembering, okay? 0 multiply by cos x and sine pi by 2 means sine 90 degree, that is 1. So 1 into sine x, 0 into anything is 0 and 1 into sine x means sine x. Got it?
sir, yes.
But now we don't have anything, we have not yet proved any formula of this kind is sine of x minus y how much. How can we find sine of pi by 2 minus x? See what we have proven. We have proven cos pi by 2 minus x is equal to sine x. Can I write this formula in the opposite way like this? Is sine x is equal to cos of pi by 2 minus x? One and the same thing. If a is equal to b, then b is equal to a. Simple maths.
Yes.
Now what I do, I replace x by what I want. I want to replace the angle x by pi by 2 minus x. X can be any angle. Why can't it be pi by 2 minus x? It can be. What we will do in this formula, we have just proved this one. We will replace x on the right hand side also by pi by 2 minus x. So we simply get sine of pi by 2 minus x is equal to cos of pi by 2, opening the inner bracket with minus sign, that will changing the signs of the inner bracket. We have got sine of pi by 2 minus x is equal to cos x. These two formulae have been proven. I hope this is clear.
Sir, yes.
Sir, yes.
Yes, all who are present here, let me ask everyone. Yeah, Man,
Yes.
consider.
Sir, yes.
Gurjot, you have just now come or you were already there in class? Okay. Gurbyan, are you understanding? I think you have come in the class first time. Yes, and Gurkirat,
Yes, sir.
are you able to understand?
Yes, sir.
Amraj, Jasmeet, Daman, that's
Yes.
okay. Now I am erasing what I have done here. So that I can prove the other formulae easily. Because we have proven sine of pi by 2 minus x is equal to cos x, and cos of pi by 2 minus x is equal to sine x. Therefore, if we want to find tan of pi by 2 minus x, we will have to write it as sine of pi by 2 minus x divided by cos of pi by 2 minus x. Sine becomes cos, cos becomes sine, and cos of sine is simply cot x over. I think now the things are easier now. Cot of pi by 2 minus.
Yes, sir.
We know cot of any angle is simply reciprocal of the tan of that angle. And tan has been just above proved equal to cot. So this is reciprocal of cot, which becomes tan. Secant of pi by 2 minus x, reciprocal of cos of that very angle. Cos has changed to sine, so this becomes reciprocal of sine x, which is simply cosec x. And last, cosec of pi by 2 minus x is equal to reciprocal of sine of that angle that is sine has changed to cos, so it is 1 by cos x. This is secant x. So all formulae have been proved. Tan also, cot also, secant also, cosec also, right?
Sir, yes.
So I am closing this screen and I will take a little time to open the next page. Sharing the next page. Now we are coming to trigonometric functions at sum or difference of angles. These four formulae, of which actually first two we have proven, but I have written here because these four and four more we will be doing. There are total 8 sum and difference angle formulae. First was actually we had proved this formula. First time we proved this formula, the new formula in this 11th class, cos of x minus y equal to this, which we have just used now in the previous formulae, complementary angle formulae. Cos x plus y we had proven equal to this. Now we prove sine of x plus y equal to sine x cos y plus cos x sine y. And similarly, we will prove sine of x minus y is equal to sine x cos y minus cos x sine y. So first of all, I take up sine of x plus y. Because cos of pi by 2 minus x is same as sine x. Therefore, sine of x plus y, I can write this as cos of pi by 2 minus bracket x plus y. Is this understood? Cos of pi by 2 minus x is equal to sine x. I hope that is clear. Because we can write this formula, complementary angle formula, yes, asking something, we can write it as sine x is equal to cos of pi by 2 minus x. Okay. So
Sir, yes.
now what we will do, we open the inner bracket with minus sign, so change the sign. We include the first two terms in a new bracket. Now use this formula again, that cos of the difference of two angles is equal to cos x cos y plus sin x sin y. Here we have again the difference of two angles. One angle is pi by 2 minus x and the other angle is y. So this is equal to cos of the first angle into cos of the second angle plus sine of the first angle into sine of the second angle. And by the complementary angle formula we have just proven cos of pi by 2 minus x is sine x. This is as cos y. Sine of pi by 2 minus x is cos x. And this is sine y. So we have proven this. Sine of x plus y is equal to sine x cos y plus cos x sine y. Okay.
Excuse me, sir.
Yes.
Sir, why we have taken minus outside the bracket in first step?
Because we use the complementary angle formula. I explained. We want to find sine of something, but we know only yet cos of something. So we want to change sine into cos. Complementary angle formulae helps to do that. Sin x is the value of cos of pi by 2 minus x. Or in sin x can be written left side, cos of pi by 2 minus x in the right side. So sin x, sine of any angle can be written as cos of pi by 2 minus that angle. So if we want to write sine of x plus y, we can write it as cos of pi by 2 minus that angle. Yes?
Sir, yes.
And still it is not in this form, though sine has been changed into cos, but inside the values yet we have to change. So we did simple algebra. So this is now x, but this value of x is this angle and y is y. So we apply this formula, and then again using the complementary angle formula, we get this result. Okay.
Sir, yes.
And so
Sir, yes.
just we do one more formula. It won't be a long calculation. It will be a smaller one because we have now at least one formula ready for sine of something. We want to find sine of x minus y because we know only one formula of sine in which x plus y is there. Sum of two angles is there. You know basic algebra that subtracting some number means adding the negative of that number. These very little facts are very important. So these things which are basic things, subtracting some number means adding its negative. Yes. So with this now formula is in the form of, this formula is now in the form of sine of x plus y, but y is to be replaced by minus y. But we have proven this formula, so we can apply this formula sin x into cos of minus y plus cos of x into sine of minus y. Remember, yesterday we did these two formulae. Sine of negative angle is negative of sine that angle, and but cos of negative angle is same as cos of the positive angle. Okay. So this
Sir,
is
yes.
equal to sin x, cos of minus y is same as cos y, but sine of minus y will give a minus sign outside, which can make this plus as minus. So minus cos x sin y. I hope this is clear. We have proven the second this also, the last one on this page also. Okay.
Sir, yes.
So I close the class here. And tomorrow we will be doing tan formulae, tan of x plus y, tan of x minus y, cot of x plus y, and cot of x minus y. Then we will be proceeding to the exercise 3.3, whose actually first four questions already done in the radian system. We have just put the values of sine 45 degree or sine 16 that. But we will be doing the new kind of questions tomorrow. Okay.
Sir, yes.
So now I close the class.